Hello, welcome. Today we're going to be looking at testing our web interface. Now, in doing this testing, we're going to be using what we call test-driven development or behavior-driven development. Behavior-driven development in the sense that we need to know how our application behaves, and through that we'll be able to write tests for them first. That is test-driven before we write the main code. So we are going to be doing this with a project that we are giving about card inventory. And basically what we want our card inventory to do is that it should properly reduce inventory when 20 lollipop are sold. You want to get the proper reduction. And number two is that it should properly add inventory of caramels when 600 of them are added. That means we want to do proper addition. Then thirdly, should properly calculate inventory of one candy type without affecting the other. That means when there is reduction or addition in one, it should not affect the other. So basically a candy inventory, not card actually, candy. We are going to be having things like lollipops, things like caramels and other things, but you are told to just pick out two to test that, and we are picking out lollipops and caramels. So you can see that when we run the Jasmine, that it is running, the three specs are all passing. So but I want us to understand how this was built, and to do that I'm going to open up the code. This is the basic folder. This is how the folder should look. You're supposed to have the spec runner, which is actually what is running here. This is, you can see the spec runner. Then you're supposed to have this src file having your code, and you're going to have the spec src folder having your codes, and the spec folder having your test. So we're going to open this test, then look at it, then see how it connects to the src. So this is the file folder you're supposed to have. So to do that, I'm going to open the code using VS Code. So you can see I have the spec here and I have the src, which is the source folder. So in test-driven development, you're supposed to write the test first, and that is why we're going to be looking at the test first. So in doing it, you just create what we call specs, and the specs are gonna, anytime you want to see a spec, it must have this it, and once there is it, then you put the condition that you want. You understand? It should properly reduce inventory when 20 lollipops are sold. Then immediately after making this statement, you now write function, and you now state how you want it to be done. So you're going to be having candy.sol. Candy is what we've already declared here. Here we have candy equal to new candy inventory, and you must have described candy inventory as the object that you want. So variable candy, so that you can now say candy, this variable candy that you've declared is equal to a new object of this candy inventory, and you now write down your test specs. So anything that you're told to check, that's what you put here after this it. Then you put a function that does that, and it's likely that you use a function that has something to do with the object. That's why we have candy.cell. You see, the first one is cell you're removing, so call it, that's why we're calling it cell. So what are you looking at? You're looking at lollipop, say lollipop, and you're removing 20, you understand, from 510. So what do you expect? You now expect the candy.lollipop, which is this candy object.lollipop, to be equal to 490. The same thing with the second one. You say it should properly add inventory of caramels when 600 of them are added. So function, the same thing, candy.buy caramels 600 added to 4. What do you expect? Candy.caramel equal to 4. So make sure you learn how to use these matchers like equal to and before each. They are called matchers, and you can use them to write simple codes. Then here we have it should properly calculate inventory of one candy type without affecting the other. Function candy.buy caramel, the same buy, the same cell. Expect candy.caramel to still be equal to this, even though there was selling happening. So that is what we did here. So with this inventory, we are going to look at the inventory src file that did the actual calculation. So in that one, we declare the card inventory as a function. Then we are giving it these various variables together with this keyword. So we have lollipops initially to be 0, caramel initially to be 0, and total initially to be 0. So this is initializing, just like you're writing a constructor to initialize. Then you now have candy inventory dot prototype dot sell. So if you equal to, so this is the function for this very one. So we have candy type, number sold, and current count, which is actually what we showed in this one, in this inventory. So candy type and the number sold and current one. So that is what was reflected. So there has to be connection between your code and the specs that you wrote in the test. Now you have if candy type is equal to lollipop, this is the actual code you're writing. This dot lollipop equals to current count. Then for let I equal to 0, then the number sold. What do? This dot, you get this. So this is actually how you do the subtraction to get the next one. So s this dot caramel equal to current count. So the same thing you do for the buy, the same structure. Buy is going to be addition, but make sure you have candy type, amount, and current count. So that is what you have there. So that is how you do the measure to checking for the sell and the buy. So in subsequent classes we are going to be looking more deeper into the next one, which is the comparison. Thank you.